With today's traffic, it takes an emergency vehicle a lot of time to reach its destination. Due to this, the patient may not reach the hospital in time, leading to an escalation in the number of casualties. These are a few statistics regarding the emergency calls and responses we obtained from GVK EMRI. Using Internet of Things, we provide an adaptive free corridor for emergency vehicles during times of crisis. This is done using our system, which consists of modules installed in traffic signals and an app in the emergency vehicle. This is a screenshot of the application, and this is our siren module.
Our vision to move towards a smarter city with improved healthcare and public welfare. Ours is a B2G business model. Initially, we will be targeting Bangalore city. We will implement our product in a few junctions near the hospitals to validate our credibility, following which we will be deploying the system to the remainder of Bangalore. We will then expand the system to other metropolitan cities. The strategy for expansion will be based on the reference we would obtain from the Bangalore implementation. We will also generate branding and market awareness after establishing the product in Bangalore by attending seminars and expos. Based on the references mentioned before and the market awareness generated, we will analyze and address the demand as it comes up. We will also scale up our team both from the perspective of addressing potential customers and from the perspective of technology development. Replacing siren with siren. Our system requires only an app on the ambulance, thereby reducing the cost and increasing the feasibility of product implementation. As ours is a B2G business model, we have a very less marketing cost and most of the money will be spent for manufacturing and R&D. There are around 150 junctions, 450 signals and 400 hospitals in Bangalore. In the first 6 months, we will be dealing with government relations, POC validation, product development and tender process. For the remainder of the first year, we will be implementing the system in around 100 signals, which comes to a total of 4,32,000 rupees as depicted. From the first year till the third year, we will be implementing the system in the remainder of Bangalore for a total of 14,30,000 rupees as shown. 1,38,000 plus the revenue generated will be used for office setup and rent. From year 3 to 5, we will expand to other metropolitan cities. We will ensure our business sustainability by the following points: expanding to different cities, enhancing our product based on customer feedback, elevating our system's functionality by branching out with new products, usage-based revenue model for sustainable profits. We are currently using the TI launchpads for the prototype. We have approached a few PCB designers to create a custom PCB which integrates Wi-Fi and RF technologies. We will identify 3 to 4 vendors to whom we will subcontract the manufacturing process initially. In the beginning, we would like to focus on R&D rather than setting up manufacturing facilities. Later, as the volume increases, we will work on the manufacturing facilities.
Coming to the market deployment readiness of the product. The proof of concept was done using the TI board's necessary hardware and cloud services. Proof of concept was implemented using our vehicles and dummy traffic signals with the modules attached. In the coming week, we will be talking with the Bangalore Traffic Commissioner towards integrating our system with the current traffic signals. Within 3 to 6 months of receiving the product development funds, we will be ready for market deployment. Following is the migration part for the upgrading technology. We will start with the prototype, followed by the proof of concept deployment and validation, which is the stage we are at currently. The Karnataka government will then validate the proof of concept and provide us with feedback. Once the proof of concept has been validated, the product development stage will begin, where we will be making the modules low power, miniaturized and modular. We will then proceed to full Bangalore deployment. Meanwhile, we will also be collecting data for our machine learning model. We will use this data for the AI/ML algorithms to perform optimization and development. After initial establishment, we will start new product lines such as application of our system to traffic management and live display of ICU beds. Coming to the business innovation. Our business model is a strong B2G contract with no middlemen, thereby reducing the cost and customizing the product to the needs of the government. We have a low operating cost which provides for sustained profits in the long run. A part of our process is to approach multiple stakeholders simultaneously, such as GVK EMRI, Government of Karnataka and TMC. We will initially deploy the system at signals near hospitals for maximum impact and then slowly scale up the system. There are a variable number of cases attended to by ambulances every month, ranging from 5,000 to 10,000 in the city of Bangalore. Due to this, we chose a usage-based revenue model where the government pays us 20 rupees per trip. We will generate branding and awareness by attending events, seminars, and expos. We will also publish articles in journals such as the Journal of Emergency Medical Services. We are using the internationally standardized frequency of 2.4 GHz for Wi-Fi and sub 1 GHz for RF. These frequency spectrum ranges have no adverse effects on the environment or the people. We have a very minimal amount of components used for the manufacturing of the module, as we have just a PCB which is to be integrated with the traffic signals. The PCB also does not have any sensor requirements, thereby reducing the material demand. The power footprint of the module is very low, ensuring nominal power consumption over a long duration of time. We will be progressing towards a better community where people will not have to wait to receive the healthcare they deserve.